Welcome to Cadence Design Systems Omnis Tutorial Tuesday, where we show you how to use our fully integrated environment Omnis in short videos of a few minutes. In this video, I'll cover the main features linked to Turbomachinery views for results analysis. Specific features are available when analyzing the results of simulations of Turbomachinery configurations fully or partially meshed with Omnis AutoGrid. Among others, the Turbo template includes the 3D, the blade-to-blade, and the Meridional views. The blade-to-blade view is accessible from the 3D view through the middle left widget in the Turbo template. The blade-to-blade view is a 2D view where all the representations of a Turbomachinery configuration are drawn in the coordinate space formed by the span position S, the azimuthal position T or theta, and the stream position M. By default, the geometry is represented with the M coordinate axis horizontal and the theta coordinate axis vertical. A single blade-to-blade cutting plane is computed and shown in the geometry tree once a simulation is loaded. The cutting plane is a 2D plane at a constant span position in the interval from 0 at the hub to 1 at the shroud. By default, the cutting plane is located at 50% span and its location can be defined in the Blade-to-Blade tab in the field span. Blade-to-blade cutting planes can also be used for results analysis of Turbomachinery configurations in the 3D view. This is done by setting the probe data type of a cutting plane to blade-to-blade. This 3D cutting plane is only defined by its span position in percentage from 0 at the hub to 100% at the shroud. The Meridional view is accessible from the 3D view through the top middle widget in the Turbo template. The Meridional view is a 2D view where all the representations of a Turbomachinery configuration are drawn in the RTZ coordinate space, formed by the radial position R, the azimuthal position T for theta, and the axial position Z. By default, the geometry is represented with the Z coordinate axis horizontal and the R coordinate axis vertical. The results shown in the Meridional view represent meridional average probe values. In other words, at a given RZ position on the meridional surface, a meridional average field, also known as pitchwise average or azimuthal average, is obtained by weighted integration of the 3D field along a circle of radius r and center 0, 0, z. The coordinate z is the distance along the rotation axis and the coordinate r is the distance to the rotation axis. The meridional surface is a 2D plane composed by the meridional mesh of each domain. Probes can only be applied to domain assemblies belonging to Omnis AutoGrid meshes. The Meridional Average tab contains advanced settings linked to the computation of the meridional average for the scene, and it applies to all domains. The following options are available. Constant weight, if activated, enables the computation of the meridional average based on area averaging. This option is deactivated by default, representing a mass averaged computation. Shrinking. For meshes that do not lie on surfaces of revolution, the accuracy of the meridional average solution is decreased at the proximity of curved boundaries. Although all boundary grid points lie on the same surface of revolution, the straight line segments forming the cell edges do not. Strong curvature and cells with high aspect ratio increase this inaccuracy. This problem is addressed by shrinking the meridional mesh by a small amount to avoid the outermost regions of the volumetric mesh. Independent shrink factors can be specified in the stream direction, shrinking axial, and spanwise direction, shrinking radial. Each mesh line is shrank individually by contracting towards its center. Cylindrical cutting planes in the RTZ system can also be used for results analysis of Turbomachinery configurations in the 3D view. This is done by setting the probe data type of a cutting plane to cylindrical and defining its anchor point and axis in the system. Thank you for watching. If you liked this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming content like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.